Scientific Notation, Lesson 5 Notes. Example number 1. Write each number in standard notation. They are giving you the scientific notation form. You need to write it in standard form. So for A, 2.6 times 10 to the 7. The 7 is positive, which means I will move my decimal to the right 7 places. So I'm going to start by putting the 2.64 over here. And I'm going to go 1, 2, 3. Start again. 1, 2, 3, 4, 5, 6, 7. So my final answer would be 26,400,000. And again, I didn't need the the decimal at the end. Please put commas in these problems. It's much easier to read the number if you're using commas. And remember, you start from the right. So you go every 3 numbers starting from the right. So 1, 2, 3, put a comma, 1, 2, 3, put a comma, and so forth. For B, negative 1.35 times 10 to the 5th. Again, my exponent's positive. So we're moving the decimal to the right 5 spaces. One, 2, 3, 4, 5. So I fill in with zeros. So for B, my final answer is negative 135,000. For C, this time the exponent is negative, so please circle that. This time we're going to move the decimal to the left. Now I just want you to notice for A and B, I knew I was moving my decimal to the right, so I started with the number closer to the left side. Since this time I'm moving my decimal to the right, I'm moving my decimal to the left, I'm going to start with my number on the right. I'm going to put my 2.7 over here. And I'm going to move it 1, 2, 3, 4, 5, 6, 7 places. So my final answer here, decimal, and then I've got 6 zeros, and then 2, 7. Now, a lot of times I will have students put a decimal, keep the decimal right here. Notice how there's 2 decimals in the answer? Well, that can't be. You can't have 2 decimal numbers. So please make sure that when you're doing these problems, that when you move the decimal and you have it where it's supposed to be, that you don't put it where it originally was. Okay. For D, again, I have a negative exponent, so let's circle that. All right, we're going to move it to the left. So I'm going to start with my number on the right. One, 2, 3, 4. So my final answer for this one, I have decimal, 3 zeros, and then 2, 3, 6. If I draw lines, here's where my decimal is now. Here's where it was. How many numbers are in between there? There are 4 numbers. The exponent was 4. For this one, my decimal's at the end, and it was here. How many numbers are in between? 7, and my exponent was a 7. For this one, the decimal was at the end. It started here. How many numbers are in between? 5, and the exponent was 5. For this one, there's where the decimal is now. Here's where it started. How many numbers are in between? 7. So that's an easy way to check to make sure that your answer is correct. So let's look at E. I have a positive exponent, so again, I'm going to be going to the right. And I'm going 8 spaces to the right. So 1, 2, 3, 4, 5, 6, 7, 8. My final answer here. And don't forget that negative out front. It would be negative 580 million. So again, here's technically where the decimal is. Here's where it started. There are 8 numbers in between, and the exponent is an 8. Again, we have another positive exponent. So we're going to move this to the right. And it's moving 3 spaces. So 1, 2, 3. My final answer is negative 2,100. So my decimal is technically at the end, and it started there. How many numbers in between? 3 numbers, and the exponent is 3. Now, let me show you something here. Just to help you, drawing the loops is fine, but I just want to show you another way that you can do this without having to draw those. Okay, so let's start with the positive exponents. The exponent is a 7. Well, first it has to get past these 2 numbers, right? So 7 minus 2 is 5. And look how many zeros are on the end. 5 zeros. Here the exponent's 5. There's 2 numbers here. 5 minus 2 is 3. And there are 3 zeros on the end. For this one, let's do all the positive ones. Sorry. Here's another positive one. So the exponent is an 8. There's 1 number after the decimal. 8 minus 1 is 7. There are 7 zeros at the end. Here the exponent is a 3. 1 number after the decimal. 3 minus 1 is 2. 2 zeros at the end. So in other words, if your exponent is positive, take however many numbers are after the decimal and subtract it, and then that's how many zeros that you will need. What if the exponent is negative? Well, the best part about this, because actually negative exponents are easier, in scientific notation, there's only ever 1 number in front of the decimal. If you look at all of these, it's 2.64, negative 1.35, 2.7, 2.36, negative 5.8, negative 2.1. Every single one of these problems, there's only 1 number in front of the decimal. So if it's a negative exponent, the decimal only has to go around 1 number to begin with. So for negative exponents, 7 minus 1 is 6. So there's 6 zeros between the decimal and the next number. 4 minus 1 is 3. So there are 3 zeros between the decimal and the first non-zero number. I don't care which way you do it, as long as you are getting the correct answer, but I will tell you this: do not use a calculator. For the test, you will not be allowed to use a calculator, and sometimes these answers are so large that when you use a calculator, it will take you to the scientific notation number and not give you the standard form, and therefore your answer is going to end up being wrong because you never change it to standard form. So please make sure you're not using a calculator. I don't care if you use a calculator to check your answer, but you got to know how to do this without a calculator. If you have any questions on example number 1, please let me know.